Welcome to a lesson with Dr. Powell. Let's take a look at finding some fibers of a function. All right, suppose we have a function goes from R2 to R2, and we define it as g of x, y is equal to x plus y, comma, 2x plus 2y. Okay, let's find the fiber over 0, 0, the origin in here, that codomain element in the codomain. What's the fiber over that guy? So everything that'll map to 0, 0. So let's think all x, y that'll map to 0, 0. Well, it maps to, the rule is it maps to this, and we want this output to be equal to 0, 0. This is the same as solving a system of equations, two unknowns. X plus y equals 0, 2x plus 2y equals 0. All right. Now, realize that both of these equations are exactly the same equation. So really, because this equation is just twice this one, so it's really like just as if I'm giving you, we just have one equation, and we just want x plus y to be equal to 0. In other words, if x plus y is equal to 0, this would fit the bill. We'd get 0, 0 out of this, just if x plus y were equal to 0. That's the same thing as all the points on the line y equals negative x, which is just a line of slope -1 right through the origin. In other words, any point on this line is the fiber, or is inside, is inside of the fiber that over 0, 0. So everything on this line maps to 0, 0 via this function g. Okay, let's take a look at another fiber here. All right, let's try another one. Let's take a look this time at 1, 2. Okay, what's g inverse of 1, 2 now? Again, it's the same basic idea. Both of these, let's see. Well, it could be. We have to think about that a little bit, right? Because what is this? We want x plus y to go to 1, and we want 2x plus 2y to go to 2. Let's write that down. We're going to get x plus y equals 1, 2x plus 2y equals 2. Now notice again we have the same idea. This equation is double that equation. Okay, this equation is double that equation. So it's really the same equation, really. So we just have x plus y is 1. So all x, y that have x plus y equaling 1 will do. In other words, all the points on the line y is equal to negative x plus 1. Okay, so now realize that this line right here, this fiber is actually parallel to the last fiber we found. And it turns out that all fibers are actually parallel lines, distinct from each other as we move along here. At least the ones that are non-empty. Are there empty fibers? Does this function not hit everything in the codomain? The answer is yes. Let's take a look at another one. All right. So let's look at the fiber over 1, 1. Okay, so let's do that. So we're looking at fiber over 1, 1. So we'd want both of these guys to be equal to 1. Okay, so we have x plus y equals 1, and we have 2x plus 2y equals 1. Now, what happens if we multiply this top equation by a -2? Then the top equation would look like this. -2 minus 2, and let's see, and -2. All right. Now we add the equations. This side we get 0, and this side we get -1. Oops. So if we assume there's something in this fiber, we get a false statement. So that means that assumption was false to begin with. Proof by contradiction. So what we end up having is that there's nothing in this fiber, meaning this fiber is simply the empty set. So there are actually lots of fibers that are the empty set. And And then the ones that are not the empty set end up being parallel lines. Now, what we have to have happen in order for that to work is we have to have that both of these, when we make equations here, that they have to be the same equation. Since this is already double that, so if this is equal to something, then this better be equal to something like 2a, which means that the non-empty fibers come from things that look like this, a, 2a. In the first case, we had a is equal to 0. In the second one, we had a is 1. Notice this is not of this form, so therefore it's an empty fiber. But if it is of this form, we end up getting a line of slope -1 that's in the plane as the fiber. Thanks for watching.